In this recitation, we are going to talk about basic skills that you will need for implementing your own datasets, which will be required by all part 2s of the homework. So let's get started. The first part we are going to talk about is NumPy datasets. Although for homework 1, 3, and 4, we're dealing with speech data, the raw audio data, or the waveform is already extracted by us. So you only have to deal with NumPy arrays. As you can see from the code, you can easily save NumPy arrays by calling save function from NumPy library. The first parameter is the file name or file path, and the second is the array you would like to be saved. Loading is similar. Pass in the file path and load function will return the array. Now it comes to pandas. Pandas is a library for table structures in Python. Although we won't provide tables as your training data, you will have to deal with CSV files to save your submission predictions. To create and save pandas table to a CSV file, you will first have to create a data frame. Then you can assign values to columns of data frame as shown by the code. We are assigning ID column to a range of 0 to 9 and label column to the range of 10 to 19. And the output table looks like this. In order to save the table to a CSV, we use two CSV functions. The table will be serialized as a CSV file and saved locally. It is also simple to load. You just have to call read CSV function, and the data frame object will be returned. Now, the most important part is the PyTorch dataset. It provides convenience to organize your NumPy data into a PyTorch native class and could be worked with data loader, which will be talked about in the next recitation. This figure shows the basic data preprocessing pipeline for PyTorch. As I mentioned earlier, most of the collecting and cleaning process is done by us, and organized data is serialized NumPy arrays. What still needs to be done is implement our own dataset class and do data transformations there. To give you a better idea, let's jump to the code. We are inheriting the dataset class and created our own myDataset class. In the constructor function, we often load some data, either from file or other forms of past parameters. Then we would possibly do some data cleaning and preprocessing. For example, normalization or augmentation. The len function returns the total length of our dataset, and the get item returns a single training sample and label at the given index. Here it is the I. Notice that we often want to reduce the runtime of this function, as the same index will be called in every epoch, so some costly operations could be moved to the constructor to avoid redundancy. Now we can create a myDataset object. The example here is that we are producing training samples from 0 to 9 and training labels of 10 to 19. If we would like to get the first item in the dataset, the getItem function or the slice of 0 would return 0, 10, where 0 is the first sample and 10 is the label, or 0 is X and 10 is Y.